Welcome to this week's video. For this video, I'd like to do another LeetCode problem and keep this theme of working with arrays on LeetCode. So last week we saw this two-sum problem, and for this week I picked another problem here. It's called minimum common value. It's also an easy one, and that's problem 2540 of LeetCode. So let's read the description here and understand what the problem is. So we have here two integer arrays, nums1 and nums2, and those are sorted in non-decreasing order. That means that they're either always increasing or they are repeating the same number. That's why it's phrased as non-decreasing order. And it's asking us to return the minimum integer that's common to both arrays. And if there's nothing, then we return -1. So let's look at some examples here. Here we have, for example, 1, 2, 3 as the first array, and then 2 and 4. We can see here clearly that the minimum integer common will be 2, right? So the output is 2. Because it's the smallest integer that is common to both arrays over here. In the second example here, we have 1, 2, 3, 6 for one of the lists, and we have 2, 3, 4, 5, and you see that the common integer, the minimum common integer will be 2 once again, because it is the smallest one that's common to both lists, right? And so to solve this problem here, we have a few ways to do it. I always like to start with the worst way so we can understand how we can improve from there, and we can also learn more about different strategies and different space and time complexities, right, to solve the same problem. So when I saw this problem, the first thing that came to mind was just to use a hash map. A hash map in Python will be a dictionary. And my idea was to just loop through the first integer array, and store every single element in a hash map. And after we have this information saved, we can loop through the second array. And whenever we find something that's already in that hash map, we know we found a solution and we can return that answer. If we haven't found anything, there's no solution and we return -1. So let's see here how we can do that in this LeetCode problem with this strategy. So for here, for example, I would start simply by defining a hash map, right? So I'm going to call here hash map equals a dictionary, empty dictionary in Python. And I'm simply going to loop over the first integer array. So for I always like to do this I num in enumerate. I think that's in Python saves us some typing. Nums1, that's simply gonna give us both the number as well as the index of that element in the array. And we're simply gonna add to the hash map the number that we just found here, and just gonna set it equal to the index. So we're just saving each number we found to this hash map. It's going to make us easier for us in the future to retrieve that and check if it already exists. And once I've done that pass, I now go to my second array, that's nums2. The same thing here, num in enumerate nums2, right? And I'm simply going to check to see if the current number that I'm at is already saved in my hash map. So if num in hash map, if that's the case, I found a solution and I simply return here num, right? If there's nothing, I return -1, means there's no solution. There's no common integer between both of those lists. So let's submit this and see if it worked. You see it was accepted. It's not a very good solution. We beat 30% of the submitted solutions in terms of time. And in terms of memory, it beats 18% of the solution, right? And if we look at the time complexity of this algorithm, that's going to be a worst case O of m plus n, where m is the length of one of those lists and m will be the other one. And that is because worst case scenario, when we don't find a match, we have to loop through the first list completely and then loop again through the second list completely, right? So we're going to spend n plus m time to solve this in the worst case scenario. And then we return -1. But now let's see how we can do it in a better way. And that's by using a technique that's known as two pointers. All right, so the technique called two pointers is a technique that's used in array problems. And it's going to have you keep track of two pointers to arrays, right? And depending on some logic that's specific to the problem, you're going to be moving those pointers accordingly, right? So when I saw this problem, I thought we could use these two pointers technique and having one pointer in one list and another pointer in another list, right? And we're gonna simply start both pointers at the beginning of those lists, and we're gonna be comparing the numbers that they're pointing to. If either one of them is bigger, we know as of now we don't have a match, so we need to move one of those pointers, right? And we're gonna move the smallest one. Because these lists are sorted in non-decreasing order, we know that we need to move the smallest one, because then it's gonna give us the better chance of finding a match of the big one, right? So if they don't match, we move the smallest pointer, and then we keep doing this until either one of those pointers reach the end of the list. And if that's the case, if we reach the end of the list, then we know we don't have a match, and then we can return -1, right? So let's see how this works here in practice. And so let's start here. I first define two pointers, P1 and P2. I set them to be 0. And again, P1 is going to be the pointer that's looping through the first list, and P2 is going to be the pointer that's looping through the second list. And here I'm going to do a while loop here. So I'm going to do while P1 is less than the length of the first list, and P2 is also less than the length of the second list. Well, that's the case, so it means that either pointer has now reached the end of the respective lists. Then we're gonna do some work here. What we need to do is to check, right, is to compare what they're pointing to. So in the case that P1 is pointing to a number that's bigger than the other one, so in this case here, nums1 of P1, if that one is greater than nums2 P2, so in this case here we have a pointer 1 that's pointing to a number that's bigger than what the other pointer is pointing to. We know we need to move the smaller pointer, right? We need to move the P2 pointer. So we're gonna simply increase here the pointer by 1. Again, because both lists are sorted in non-decreasing order, if we found a number that's bigger than the other one, the only chance we have to find a match is if we move the smallest pointer further, right? And we're gonna keep doing that in this loop. The other case here, naturally, is if the nums2 pointer, if that one is greater than my nums1 pointer, if my P2 is pointing to a bigger number than my P1, then I do the exact opposite, right? So then I would increase the P1 pointer by 1. And the only other option here to reach this else here, the only thing that could happen is if they're both the same, right? Because if nums1 is bigger, we are covered here. If nums2 is bigger, we cover here. The only case here is if they're matching, if they're the same, in which case we found a solution. So we can return then either nums1, what's pointing to in nums1, or what's pointed to in nums2, because they're the same thing, it doesn't matter. So I can return here nums1 P1, but it could have been nums2 P2, right? So that's pretty much it. And if we don't find any match, we're gonna exit this while loop here without returning anything, and we need to return here -1. So let's see if this works here and submit it. And you see here we improved a lot. Now we beat 86% of the solutions submitted. In terms of memory, we beat 38%. And it's interesting here because in terms of time complexity, this is still a O of n plus m time complexity, and that is because we usually deal with that in the worst case scenario. So in the worst case scenario, there could be two lists that's going to force you to loop through all of them, right? To loop through both lists all the way to the end. So that's why on paper, it's still a O of n plus m time complexity. But in reality, you know, for a lot of the inputs, we can find a solution much faster. If you look back into the first solution that we showed, we saw that for sure, you know, to find a solution, we're going to have to loop at least through the first entire list to build that hash map. But here, it could be that we can find a solution much sooner without having to go through an entire list, right? Without having to go through a list all the way to the end. And that's why this solution here is faster for a lot of the inputs. But that's pretty much what I have for this video. It was just a shorter video showing you how to solve this array problem here. And if you have even a better solution, feel free to comment that. I'll be willing to discuss it and see how we can improve these algorithms. But thanks for watching the video, and I'll see you next time. See you.